Hello and welcome to some super fun SAT problems with Mrs. Hendry. We have, first of all, if negative 20 over 7 is less than negative 3z plus 6, which is less than negative 11 over 5, what is the greatest possible integer value? Remember, an integer is just a number, like on the number line. Integer value of 9z minus 18. Now, what hopefully is going to stick out in your mind or in your eyesight is that 9z minus 18 is a multiple of negative 3z plus 6. Because if we simply multiply negative 3z plus 6 by negative 3, distribute, we end up with 9z minus 18. Wow! So what are we going to do? We are going to take this entire inequality and we're going to go through and we're going to multiply everything by negative 3. Times negative 3, times negative 3, times negative 3. Because here's the reality. We don't care what z is, but we do care what 9z minus 18 is. So negative 3 over 1 times negative 20 over 7 is 60 over 7. And then these are changing, not that that really matters. Multiply by the negative 3. Negative 3 times negative 3z is our 9z. Negative 3 times 6 is our negative 18. And then also changing. Negative 11 over 5 times negative 3 is 33 over 5. Now, these are, regardless, doesn't matter. What we're looking at is what integer is going to live in between these two fractions. So 7 goes into 60 8 times with 4 left over. 9z minus 18. And 5 goes into 33 6 times with 3 left over. So what is the greatest integer in between 6 and 3/5 and 8 and 4/7? The largest integer is 8, and that's the answer. Next we've got if 2a plus 3c minus 5b equals 7. So let's go ahead and write that because we're going to have to first get it in order and then we're going to work a little magic with algebra. And 13b minus a minus 6c equals 10. Okay, so that's negative a plus 13b minus 6c equals 10. Which of the following is the value of a plus b? So once again, we don't need to know a. We don't need to know b, but we do want to know a plus b. So probably the easiest thing we can do with this problem is realize that if we want to know a plus b, what we need to unload is we need to get rid of this c term. And we can easily get rid of the c's using elimination by multiplying this top one by 2. If we multiply this top equation by 2, we get a newly transformed equation. I'll write it to the right. 2 times 2a is 4a. 2 times negative 5b is negative 10b. 2 times 3c is plus 6c. And 2 times 7 is 14. So, new and improved equation over there. The bottom equation, we don't need to do anything to it. We just need to move it over. So, negative a plus 13b minus 6c equals 10. Now, just like we learned in Algebra 1, if we add these two together, we're going to get these c's to eliminate. One's a positive 6, one's a negative 6, which leaves us with 3a plus 3b equals 24. And remember, what are we trying to find out? What is a plus b? How do I get to a plus b? I just need to divide both sides by 3. 3's cancel, 3's cancel. I get a plus b equals 8. And that is the answer.